Okay, well, we're down to our last section of the year, and this is called Sketching Rational Functions. This is going to be a 2-day section. We'll have half the problems in tomorrow's assignment after watching this video tonight, and then the other half on the following day. First of all, we got to go through what a rational function is. Rational functions are another way of saying an inverse variation function, which you remember from the last video. Those are of the form y equals a over x. That was the candy problem, where I said if you had 100 pieces of candy and one person gets it, that person gets all the candy. But if you double the amount of people, if there's 2 people splitting the candy, they each get 50 pieces, and we inversely varied. As we doubled the amount of people getting candy, each person got half as much. So inverse variation functions are part of the rational function family. The parent rational function is y equals 1 over x. I know we would have sketched that, I'm pretty sure, on the last video, if not for sure in our homework in 12.1. And the parent function means the most basic kind of that function. All right? And we're going to sketch and look at the parent function again. The domain and range of the parent function is going to be all real numbers other than 0. So I can plug in any value for x other than 0, and it will give me any number for y other than 0. That would be my domain and range of that. Okay, so first of all, a couple reminders. Here's the parent function. I wanted just to add this into this diagram real quick. You'll notice that we are adding nothing here, and we're adding nothing here. So I have a vertical and horizontal asymptote. My vertical asymptote I can find here. It's at 0. And my horizontal asymptote is here. It's at 0. So let me actually quickly sketch those in. And I would always recommend you do this. In fact, I'd ask you to do it on quizzes or tests. And okay, so here's my vertical and horizontal asymptote. And that means that my hyperbola will never actually touch these 2 lines. They will approach these but never touch. And then for some other review items here, let me erase this out of here. We don't need this. Remember, if A is positive, your asymptote will be, I misspoke, your hyperbola, I meant to say, will be in quadrant 1 and quadrant 3. So I know right now my hyperbola for the parent function is going to be up here in quadrant 1 and going to be down here in quadrant 3. I'm going to quickly make a table of certain points on this hyperbola, okay? And so I made this table here, and if I plug in -5, I'll get -1/5. If I plug in -2, I'll get -1/2. If I plug in -1, 1 over -1 is -1. When I plug in positive values, 1, 2, and 5, I'll get the same fractions, just opposite signs. So now I can start actually sketching those points, and you'll notice I started sketching them like here's 1, 1, and 2 and half, and 5 and 1/5. And then as best I can basically draw in my hyperbola. I wouldn't make you use graph paper for this. If you're comfortable with it, you can. But there is the parent function, parent inverse variation function. It has 2 asymptotes. These are the lines, again, that the hyperbola approaches but does not touch. The domain for this, I can plug in any value for x except for 0, and my range is any y value except for 0. And again, we mentioned we had a vertical asymptote and horizontal asymptote. X equals 0, there's my vertical asymptote. Y equals 0, there was my horizontal asymptote. So we talked about this already. Remember, the rational functions, these are still hyperbolas, but they will have an h and k value. I've kind of already talked about that. This tells us what quadrants the parabola is in, and it tells if it's stretched or shrunk. If A is greater than or equal to 1, the absolute value is stretched. If A is between 0 and 1, it's shrunk. A couple key things about A. Remember, if A is positive, let me go back a slide. If A is positive, this would probably be the most important thing, even more important than the stretch and shrink. If A is positive, your hyperbola is going to be in quadrant 1 and 3. If A is a negative number, you know your hyperbola is in quadrant 2 and 4. I'd say that's probably even more important than the stretching or shrinking, although we've talked about stretch or shrink the whole year. if the absolute value A is a number greater than 1, you know that stretches the hyperbola. If it's between 0 and 1, it's shrunk. Okay? And then the next thing, the K and H, we've already talked about that. The K indicates an up or down shift in the horizontal asymptote. Whatever K is your horizontal asymptote. In fact, we'll talk about that more in a minute, and I'll show you that in action on my next example. And then H tells me the left or right shift in the vertical asymptote, and H is the opposite of what it says. If you see -1 here, that doesn't mean your vertical asymptote's at -1. It means +1. I've said this in class many times. It's what do you plug in here to make this 0? That's how I always remember it. What do I plug in here to make this 0? And then whatever this is my, then that would be my horizontal asymptote. So here would be an example problem here. I want to sketch this. So let's take a look at a couple things before I start clicking my slides. The first thing I notice is that A is +1. As soon as I see A +1, that means I know my hyperbola is in quadrant 1, quadrant 3. It's going to look up here and here. And then here's the next thing. I know right now I have a asymptote at -3, a vertical asymptote at -3, and I have a horizontal asymptote at -2. Okay? So again, A being 1, hyperbolas in quadrants 1 and 3. Since K is -2, I have that horizontal asymptote here at -2. And since H is 3, I know my vertical asymptote's at -3, or in other words, if I plug in -3, I got 0 there. Now I said from the beginning, since A was 1, I know my hyperbola is in quadrants 1 and 3. So quadrants 1 and 3 would be considering these asymptotes. I'm going to have a hyperbola branch up here and down here. And then I'm going to make a table real quick, and I'm actually going to plot points so I can help do this. And in fact, on my quizzes and tests, I'm going to ask you to list some points. So I did here. I'll plug in some points that work out nice. If I plug in -2, I get -2 plus 3 is 1, and 1 over 1 is 1, and 1 minus 2 is -1. And then I plugged in -1. Now this gives me a fraction. I'll just deal with it. -1 plus 3 is 2. I have 1/2 minus 2, and that's -1.5, and so on. So you can see I plugged in a few points there. I also plugged in some negative points on the left side of the vertical asymptote. Like if I plug in -4, -4 plus 3 is -1. 1 over -1 is -1. Minus the 2 is -3, and I think you get that. Well, here you can see I'm starting to develop my hyperbola, and I can now take my pen and just draw my lines through it. There's my hyperbola. And I have a horizontal asymptote at y equals -2, which you can see there. And I also have a vertical asymptote. Maybe I should have wrote that in. It's at x equals -3. Okay? And that's what we're basically doing on these questions. Let me see. I think those were the 2 examples I did. I don't know if we need, I didn't want to make this video too long. I think that will get you through what we are doing over the next 2 days. We are going to be graphing rational functions. Rational functions mean inverse variation functions. And again, the key things, use your A value to determine what quadrants you're in, and then use H and K to determine your asymptotes. Once you have your asymptote sketch, you can make a table, get a few points on each branch, and sketch this, and you should be good to go. All right? Good. I kept my video to under 10 minutes. That's a good deal. I will see you tomorrow.